Welcome back, and let's go ahead and get started on horizontal asymptotes and end behavior. And if you remember this from when you were in pre-calc, you were doing problems, okay, that said as x approaches infinity, well, what does your y value approach? And you should notice this limit problem is the exact same thing. It says as x approaches infinity of this function, what is y approach, right? That's what goes here. What's the y value? Well, remember when we're doing, all right, end behavior, let's first look at the graph. Well, as x approaches infinity, well, let's look what happens to my y values. Well, they continuously go up. So I could tell that it's infinity, right? Our y values approach infinity. And from the left, as we go to the left, right, to negative infinity, you can see my y values continue to go up. And so it also approaches infinity for my end behavior, okay? Well, let's go ahead, and you'll notice that usually whether you go to positive infinity or negative infinity, your end behavior will always be the same from the left and the right for the most part, all right? Look here, all right, if I was to plug in a million or a billion into this function, this -4 is insignificant, and so is this -2. It's not going to affect our function. So when we are looking at end behavior, limits of as x approaches infinity, we only care about the highest degree on the numerator and the highest degree on the denominator. So the highest degree on the numerator is x to the third. So I'll write x to the third divided by, well, it's just x. Okay, this is the same thing as x times x times x divided by x. That cancels out, and I'm left with x squared over 1. And now you could see clearly why we're going to get infinity, because we're going to just plug in a really big number in here. Let's say, I'm just going to say huge, right? Infinity. Huge squared divided by 1 is going to equal, you know, more huge. It's just going to keep getting bigger and closer to infinity. So what is a horizontal asymptote? Well, it does not exist. Okay, because the numerator is larger than the denominator. Let's go ahead and look at this example problem. Okay, well, we want to find out what is the horizontal asymptote. Well, as we go from positive infinity to the right, you'll notice it's getting closer and closer to what looks to be 0. And same thing over here. As I go to negative infinity, I'm getting closer and closer to the x-axis, which is negative, which is 0 as well. So I'm expecting the equation to be the same. So let's look here. We can't immediately look here, kind of tricky, because the highest degree term on the numerator is this one right over here. Okay, so I'll go ahead and write that down, negative x to the third. Down over here, you might think, oh, x to the third is my highest degree numerator, but you have to be careful because we need to, right, there's this x right here, and there's this x to the third right there, so we need to multiply them, and we're going to get, well, x to the fourth. So this is going to be x to the fourth, and I'm going to get, well, negative, all right, x times x times x, all divided by, there's 4 of them. Well, these cancel, and I'm going to be left with -1 over x. Well, as we plug in infinity to our equation now, we're going to get -1 divided by a huge number. And basically, all right, if you think about it, and I'm going to show it over here, as we get bigger and bigger into our denominator, okay, we're constantly going to get smaller and smaller, because it's like taking $1 and we're going to break it up, give it to 10 people, right? Let's take $1 and we're going to evenly split it among 10 people. So everybody's going to get 10 cents. Well, over here, you're taking $1 and breaking it up to 100 people, and that's 0.01. And then over here, it's 0.001. So again, you can see that a problem like this, all right, if your denominator is larger than your numerator, well, it's always going to approach 0, because we're going to divide it, the numerator by a large amount, and break them evenly up into more groups. All right, so this is 0, and you can see it on the graph. So what is the horizontal asymptote? Well, the horizontal asymptote is y is equal to 0. Okay, the horizontal asymptote is right over here. Okay, last thing I want you to notice is that it's okay. You see that right here? It's okay. It's okay to touch horizontal asymptotes. Okay? So when you thought of vertical, you can't touch vertical asymptotes. The vertical asymptote right here, right? We can't touch it. Our function actually does not touch it because it would be dividing by 0. But horizontal asymptote is asking for end behavior, and end behavior has nothing to do right, with getting 0 on the denominator. If anything, we're getting bigger, and that's why we get 0, and that's the horizontal asymptote, right? So it's okay for it to cross your horizontal asymptotes. Okay, let's look at this next problem here. Well, again, you can see as I go to the far right, okay, my y values, all right, to infinity, my y values are approaching, looks to be 2. And from the left, at the same thing, it approaches 2 as well. All right, and you can see this one also crosses your horizontal asymptote. So let's look at this. We'll focus on the highest degree numerator. So it's going to be, well, 4x to the 5th divided by, and it's this right here, 2x to the 5th. Well, would you look at that? We have the same fact, the same x's on numerator and denominator. These cancel out, and we're just left with 4 divided by 2, which is just 2. And that's why our horizontal asymptote is y is equal to 2, which is this right here. This is what our function is approaching long term during the end behavior. Okay, so those are the 3 scenarios. If the numerator is larger than the denominator, well, it goes to infinity because it gets bigger. If the denominator is larger than the numerator, right, our horizontal asymptote is always 0. And then if it's the same, we cancel them out. Whatever the coefficients are, that's what your horizontal asymptote is. Okay, let's look now at limits and vertical asymptotes. All right, now this is the one I was telling you. As x approaches 0 from the left, so from the left, the 0 is right here. As we approach 0 from the left, well, look, it keeps going down. This is negative infinity. Over here, as we approach it from the right, so as I get closer and closer and right, well, this is going up to positive infinity. Therefore, as x approaches 0, 1 divided by x, right, this is essentially going to be, well, this is going to not, or does not exist. That's what the DNE stands for. Okay, because, well, first of all, as it approaches it from the left and the right, we get 2 different values, but infinity again is not a real number, and so we can conclude it does not exist. Okay, now if you're wondering why is it as we approach 0 on the bottom, it gets bigger, I want to give you an example just so that you really understand. Let's look at this example here. I'm going to just take this right here, and hopefully this example will really help you understand, okay, what I'm talking about here. So I hope you can see that the denominator is getting smaller and smaller and getting closer to 0. And basically what this is asking us is, if I have $4, right? Let's say I have a bag and the total money in the bag is $4, right? But they're all in 25 cents. Well, how many quarters do I have? Well, 4 quarters go into $1. So if I have $4, I'm going to have 16 quarters in order to get 4. Okay, well, look down below. What if I have a bag that is equal to $4, but they're all in 10 cents? Well, I'm going to have 40 dimes, right? I need 40 10 cents to give me $4. Well, look at this bottom problem down below here. How many dimes until you get to $4? Well, that's going to be 80 dimes. And last but not least, how many pennies are in $4? Well, that's got to be 400 pennies, okay? So you can see a big difference here is as we divide by smaller numbers, our y values get bigger because it takes more of this small amount to fit into the number in the numerator. It takes more of pennies to fit into $4 than it does with quarters. All right, that's just a quick example if you needed to understand that. All right, so let's go ahead and continue on. Well, here we are. It's asking us for the vertical asymptote. And first, just let's look at the graph, right? If we look at the graph, my vertical asymptote is right over here at 2. You can see it clearly on the graph. Well, where do you see that with the equation? Well, again, it has to do with the denominator, right? Because what number do I need to plug in here to get 0 on the denominator? Well, 2, because 2 minus 2 gives me 0. Therefore, I can conclude, okay, that my vertical asymptote has to be x equals 2. That's the number that we need to plug in to get 0 on the denominator. Or if you weren't sure, you can always take the factors in the denominator and set them equal to 0. X minus 2 equals 0. We add 2 to both sides, and we're going to get x is equal to 2. Okay, I'll go ahead and do this right here. X is equal to 2. And that is my vertical asymptote. Okay, so if you look here, Okay, again, example, well, it says, what's the limit as x approaches 2 from the left? Well, as I approach it from the left, okay, I'm going to get closer and closer to negative infinity. And down below, as I approach it from the right, I'm going to approach positive infinity, okay? So when it's asking me what's the limit as x approaches 2, well, it does not exist. 1, because we get inconsistent y values, and 2, even if we did get infinity for both terms, infinity is not a real number, so we can conclude it does not exist, all right? So anytime you're approaching, okay, the number that gives you 0 on the denominator, it's going to be a vertical asymptote, and it's not going to exist. And you'll notice we can't factor this any further, and that's why there's nothing for us to do. We can't factor this, right? Where other problems we could factor and cancel the factors out, well, we can't in this case, and so we're kind of stuck here, and this is basically all we can do. So hopefully this helps you to understand a little bit of horizontal versus vertical. We'll go ahead and do the homework problems in the next